Okay, we'll go ahead and get started here. So, when Kurt sent me a message a week or two ago saying that we were going to do a breakout session, and then I was going to talk about system operation and maintenance, and he was going to talk about new sales. I said yes, because I can answer about 50 sales calls in about an hour. So that's sure going to be a lot better than you guys having to sit and wait for Kurt or I to call you back this summer. So hopefully it'll give you a little insight, because I know you guys are all here because you have drip systems and you want to learn how to make the most of them and learn how to manage them the best, so you can get to yields where Kelly and the other guys are at. So I guess a little introduction about myself. Travis Rokey. I grew up here just west of here, Sabetha, until a year and a half ago. I actually moved down to Lamar, Missouri, Southwest Missouri. So I've been NutraDrip for, let's see, since 2016. Did a lot of the automation and service and installs. So I kind of turned a lot of the automation over to Carlos. He's done a good job with that, and now I'm more in sales and service in southern Missouri. So with that, I guess we'll go ahead and get started. And again, I'm just going to go through some of the stuff that I've learned and seen as NutraDrip as a whole. If you guys have questions about specific scenarios based on your operation, your setup, definitely interrupt, and we'll answer those questions, because that's what's really going to matter for you. So understanding your field design. I think every drip system we have or we install comes with a design that's done by an engineer. That's a very valuable piece of information. That's like a manual for your John Deere tractor. This one, just don't stick under your seat and let it collect dust. Hang it up in your seat container, because there's a lot of good information on here. Anywhere from what your water source pressure should be, how much flow your zones are going to be handling. We'll dive in a little bit deeper here in a second. But really good information on that. Yeah, you should be able to see that fairly well. So each zone has this bit of information on it. The zone number, that's going to be the zone. It'll represent what your controller says is the valve. So valve and zones are used interchangeably. So that's obviously going to make a difference where your water goes in the field. Your acre number, again, comes in really valuable when you are going to put fertilizer on. So if you wanted to put on X amount of gallons per acre, add up how many zones you're irrigating, and then how many acres you have in those zones for your total fertilizer quantity. And those are usually pretty accurate acre numbers. And then below that, you have your gallon per minute per zone. So when you're running that zone, you should be flowing that set rate after the zone is pressured up and full. It may vary a little bit from your design if it wasn't installed exactly how the design laid it out, but we should be able to get that corrected after your first year of running it, get a more accurate number. Valve pressure, that gets set at the beginning of the year. It shouldn't really need changed. So John Maxwell, when he designs these, he knows this zone needs 22 psi to get even water distribution. So if that zone's at 22 psi, you're going to get a good even coverage. Actually, the uniformity at 92% is how even that zone is watering. So I think most of all of ours are at real close to 92%, and you won't be able to see the difference visually or even with a yield map or yield monitor at that percent. This next number is probably the most valuable number on here. 0.015 inches per hour. So you run your system for an hour, you're going to put on 15,000th of an inch, which is fairly slow, but obviously you're able to run it many hours. So to put a 1/4 inch on, say you had corn on here, wanted to put a 1/4 inch on, that's going to take about 17 hours to get your 1/4 inch. And I don't know, maybe Tim or Kurt talked about it more this morning, or they'd be better guys to answer your questions as far as how long should I run or can I run per set? Because I know if you do run too long, we start sending water too deep or too far up to the surface. So paying attention to your moisture probes and your soil type when you are watering to know how long you should run for. The irrigation block number, that is the number when John Maxwell designs these. He knows if he has the right amount of flow from your well, if he has that number, he figures out how many blocks you can run per set. So like these two are in block 1, so they would get run together, or could get run together. You don't have, it's not that you have to, but he just assigns that block to it. The next 2 rows of information are your drip tape size and flow rate. The NetFM DNC PC is that DripNet PC, your pressure compensated tape. 875 is your size. That's your 7/8 drip tape. The 5/8 is the smaller, and then there's inch, which is the bigger size. And then your emitter and emitter spacing and pipe mill, or the drip tape mill. Then your valve information, how many tapes are per zone, and then the spacing on it. So that kind of gives you what's supposed to be happening in the field if your system's running based off the design. All right, I zoomed in on the pipe on the edge of the design just so we could see it a little bit better. The critical information here is after install would be where your valves are located. So these two triangles pointed at each other, that's your zone valves, your blue zone valves that turn on and off and regulate the pressure. So yeah, those kind of give you an idea where they're at. Obviously, you don't have one at every zone. We kind of keep them together so you don't have to go around as many spots. These little triangles with a number inside are your banjo flush valves. So it's a 2-inch one, and we paint these red on the sub-main side of the field. And then on the flush side, you have your 3-inch orange flush valves, and I'm sure a lot of you guys are aware of that. So just so you know, I think after 2018 we started color coding them. So that's the blue is your zone valves, red is your sub-main flushes to clean out this section of pipe, and then you'll have your orange flush valves on the flush end to clean out the drip tapes in that flush pipe. Yeah, here I got a picture of them. Hard to see the color, but obviously your zone valves, a lot of them are banked together. Your red sub-main flushes and your orange banjo flushes for your flushing the drip tape. Here I just stuck a picture up of checking your valve pressures. So when you do the sign up on the startup contract we send out in the spring, our guys go around and set those pressures of your zone valves to that set pressure. That they shouldn't need adjusted throughout the year. And again, that pressure number is on the design. Some designs will have a flush pressure. It'll be labeled flush pressure, and it may say like 30 psi, maybe a little bit more. So when you open your orange flush valves, this needs to be set at 30 psi or whatever it says, because John Maxwell figured out that it needs a little bit more pressure to clean the tape properly. But there's only a few systems that need that, really the rolling hills where that's at. I always keep one in my truck. I just buy a liquid filled pressure gauge, put an air chuck on it. I always keep one of these with me. We should leave one at every new job we install, because keep in your pocket when you're going out and checking things, you can just stick it on there. If your flow's not right or something doesn't look right, you know that zone's at least pressured up to what it should be or isn't, and then you got a problem. Because if your pressure is less, your zone will be flowing less as well. A valuable tool. Okay, so on the flushing, as far as how often to flush it, a lot of guys ask that. When you have really clean well water, which down in Southwest Missouri, they have very clean well water because it's really deep water. I recommend flushing once in the fall and once in the spring. Your fall flush clears out all the lines just from your year of running, and then your spring flush will clear out anything that worked its way back into the drip tape over just sitting over winter if you had saturated soils. So again, run these flush valves till you see clean water. Open them up. When you flush the system, say you got a 500 gallon a minute well, and you have each of your zones are 250 gallon a minute, you would want to run only one zone, because you're going to be flowing higher flows through that zone. So cut back the amount of zones you flow so you have that required pressure to properly flush. And it'll depend on your field how long it runs, but it could take up to 15 minutes to finally get clean water, and that's important to get your drip tapes clean at the beginning of the year. I'll also show some pictures later on where some emitters that are plugging up and they're in a critical situation. Also, I might go back to that design picture. You'll notice each of our zones has 2 flush valves. So here we got one zone, we've got a flush valve on both sides. To clean out this flush pipe properly, open one of them at a time. That way all your water runs out one or the other. They get a better flush on that pipe. Okay, so Tim often says you can't manage what you can't monitor. So a drip system, there's not much you can see above ground. You can hear a little bit going through the filters. We're not as privileged as the pivot irrigators and being able to see the sprinklers go around the field, watch your windshield every once in a while. So we can use sensors to monitor how our drip system, the health of our drip system, really. So flow with your flow meter. Every system has a flow meter. Pressures with your pressure sensors, and then your pressures on your zone valves. And we're also using imagery to tell what's going on in your field. So I'll kind of go through each of these just a little bit and show you some examples of some systems that aren't working and are working based on these sensors. All right. So I think we've got several different controllers. So each of these controllers pertain to different guys. This here is our NMC DC controller lineup. So this is your platform online, what you're watching. You have what zones are running, your flow, and if you scroll down here, you'll see your pressures. So when the controller, all of our controllers know what the flow is supposed to be. So back at that one, if we go off that one design, it was 95 gallons a minute per zone. So the controller knows that's what is running that zone. It calculates how much it should be flowing. So our arrow should be in the center of this gauge. So we're flowing just a touch high on this system. Probably have a few leaks or an extra zone turned on. On the right is our net beat. Similar setup. You got your flow gauge. You have your pressure reading, and then this one also had a moisture sensor plugged into it. And I think those guys that have them are familiar how to get to the schedule, see the program that's running, and see the valves or operation. So valuable information as it's running. Here is a graph off of a net beat system. I think it's one from last year. It's a flow. You probably can't see the numbers here. I think we're from 0 all the way up to 1,200 gallons a minute. We were running here at like 450 gallons per minute. We were running a set of zones. It switched zones, and our flow went up really high. Then as it filled that zone, it started tapering off and then leveled out. So that's a healthy drip system right there running. So again, where it evens out at is what the average should be, or what should stay at for that specific shift of zones. Here later on, something went haywire. I'm anticipating what happened there. It went to switch zones again, and it couldn't get the zones to turn on, or we actually had a delay for getting them turned on. So it went all the way to 0, and it slowly started climbing and then settled out, probably a little lower than it was supposed to. And the controller threw an alarm saying, hey, we have low flow, our valves didn't open soon enough, and it just shut off. And again, you should get alerts on what's going on when it does shut off. Here's the pressure, same system. We were running 60 PSI. We shifted zones. Our flow went up and our pressure dropped. That's normal. Hydraulics. And then our pressure steadied out again. Here's when the third shift of zones kicked on. Our pressure spiked because that water had nowhere to go. I think one eventually then opened, but then it shut off and went to 0. So on the net beat controllers and our Galileos, we can build these graphs with our flows and pressures. Those give really good information on what's happening. I got one more graph. The NMC controllers don't have this graphing feature. So what we did on this one was took our the average flow of that shift, and just exported it to Excel and put it in a graph. So this is a season worth of running. We had 3 zones, probably the different colors. This third zone is a little smaller. So over the year, our flow gradually started decreasing. And the reason for that was we had a little higher iron than we anticipated when we first drilled the well. So our flow slowly started dropping off. So we're headed in a dangerous direction, but we aren't in a dangerous spot yet because we still got flow, we still have time to clean it up. But definitely something we need to watch, because it wouldn't be more than just a few years, and this system could be plugged up if we didn't treat that iron. Okay, to the imagery. We've tried a lot of different imagery, satellites, drones, and some from airplanes. We've struggled to get good data from them, good reliable data. What we have found is daily satellite imagery has done pretty decent for us. This is a field down my direction. I think we got about 170 acres here. The main line comes down the center and then cuts out here and flows back north. So what I'm seeing in this system, we had just a little bit of the history of the weather we had down in southwest Missouri. But it's extremely dry. Only had like 2 inches of rain since middle of June, and he has only about 18 inches of topsoil before it's just solid rock pretty much. So we've seen our stress show up really fast, and that's probably the best way to figure out all your problems on a drip system is have a dry year and not enough water. All your problems come to the surface. So what I started seeing here was we weren't getting enough water to the outsides of this system. We were dry here, starting to get dry over here. You can see this zone was getting ample water, and that's where our soil moisture probe was. So based off our soil moisture probe, we were doing a good job watering. And then this zone wasn't too bad. What was happening is we weren't getting enough pressure. We were running too many zones, trying to get as much water on as we possibly could to keep the crop alive. And this was the higher part of the farm, the outside edges, and they weren't getting enough water. He ended up having to chop 53 acres here because it just was starved of water. So it was a sad situation, but well, there wasn't a lot we could do because we didn't have enough water. But if I would have looked at the imagery sooner and done maybe some field verification, I would have seen this was starting to stress a lot sooner, and we could have tried to fix it. So I think Kurt, I know, gets some imagery from Climate Field View, so he's able to that's usually good enough imagery to pick up on zones that aren't getting enough water. It's hard to pick up leaks with satellite imagery just because it's not high enough resolution. So that's when the drones with thermal cameras or like a high resolution MDVI does a lot of good. And yeah, we're 36 zones, 500 acres, and 1,000 gallon a minute well. So he's very short on water and wasn't prepared for a year like this. Yeah, let's see. The question was if he was running the zones at the same time on the edges. That was one of our problems too. We were running too many zones down in this section. We should have been running more zones. Like there's a couple zones here. Should have spread that water out. The pump sits actually 1.5 miles north of here, so we're pumping water a long ways. And just by the time I got here, it ran out of pressure. So. Yeah, so I think just getting your free satellite imagery from the. I know there's a lot of suppliers or a lot of people that have that available. Just watching that on a weekly basis is a good option to start with because it does get fairly expensive to get drones in to micromanage it. I am going to point out here too on this field, we had a few tapes get kinked, so it was actually you could start seeing it, but all across the field there was a dry strip. So like I said, being really short on water and not getting enough rainwater, you start seeing your problems in your drip system. And if we wouldn't have been running so many zones, we would have seen that in our flow. This zone was not flowing what it should have been, what the design showed. So between the flow meter and the aerial imagery, we were able to pick up on that. Okay, any questions about monitoring and watching your drip system via meters? Not everybody's, because Carlos, Kurt, and I don't have the capacity to do that, but there is quite a few that we do watch that tend to have more problems or we're trying to learn something on. If you call us with a question, generally we watch your controller and make sure it's working for a while before we turn to somebody else's. Sure.
Go back and look on the systems, or is that our job to call you guys and say,
yeah, we were able to do that. We were able to watch everybody's system when we only had 10 customers. We're getting big enough now where it's better for the farmer to be aware of their own system and watch those flows. Like on the NMC, like what you got, Roger, you can go in and export your irrigation logs into an Excel, and you can just figure out all your average flows and put them in a a timed graph.
You can watch it here.
Mhm.
Start going down.
Sure.
Kurt just called me in the past and said, sorry. Kurt just called me in the past and said, hey, it looks like your flows are starting to go down and maybe we got some iron buildup. And I didn't know whether you guys routinely did that or if it's just our job to make sure we were watching that. I better watch it, is what you're saying.
Sure. Yeah, that would be preferred because
Okay.
there's a chance we may catch it if we happen to
All right.
look at your controller, because we try to go through a lot of them. And like the systems I have down in Southwest Missouri, I try to watch those, but we're not able to watch everybody's. So if I can inform you guys of what may be going on, it'll help you guys be able to watch that a little better.
You were talking about just in the flush system, just opening one flush valve. If
Yep.
you have two of them on a zone, only open one, or can you open both?
Yeah, what I actually like to do, if you open both of them, you get a little more velocity through the tape, but then go ahead and close one down for a little bit and then open the other. That way you can flush that pipe out that all the drip tapes are hooked into. If you send water just to half of it, you're going to get a little more velocity to clean that pipe out a little better. So I know a lot of our systems, especially when they're on hills, if you open both of them up, water just goes to the downhill one. So if you shut that downhill one after it's clean, let it flush out the top side, you'll get, there's still usually a little bit of junk in there to clean out. But I think a lot of your systems are pretty flat, so I think you'd be okay opening both of them.
Okay.
Now, if you pay to have it done, you still need to be doing that flushing. Like
So we
winterization.
take care of the spring one. If you do your spring contract, the spring startup, we take care of that first spring flush. I forgot to mention if I mentioned the good clean well water, but if you have pond water, you tend to have a little bit more silt and stuff get in your drip tape. So to flush it one time in the middle of your season, if you have to irrigate a lot, I would recommend doing that. And then if we do the winterization in the fall, obviously the air cleans it out really well. So that would take care of that final flush. The high iron systems, I like in that picture I showed of the orange water, I would recommend if you're irrigating heavily, doing a flush weekly or bi-weekly or every other week. Keep that iron from building up in the emitters, getting it flushed out. No matter how often you flush a high iron system, you still get orange water out. In the effluent, when you're running effluent through your system, I would recommend every 2 weeks or at least once a month, depending on how heavy you're irrigating to flush it. Just because we have silt wants to build up in your drip lines, settle out. Okay, so I'm going to go through some problems we've seen, and obviously since we've seen them, we've usually can figure out what was going wrong with them, and I'll just pass that on, maybe do some preventative maintenance for some guys. Okay, so when you get your drip system, for like your SAMI, actually all your filters have a pressure gauge on your top manifold, and the little dial below that, and a little command filter. That gives you valuable information as to what your pressure is before your filters and after your filters to know how dirty your filters are. So that black arrow on there, when it points down to this small 1-inch pipe, then the pressure gauge reads how much pressure is on top of the filters, so how much pressure you got coming from your well. You turn it up to the left to this other little, it's usually a blue elbowed fitting with a tube connected to it. That's going to read the pressure after your filters. So we want to keep that pressure differential less than 7 if possible, just so you aren't burning extra energy going through your filters. But as that number gets higher, your filters are plugging up, and then most of the controllers or backflush controllers are monitoring that, and they're going to flush your filters automatically to keep them clean. But again, if you got something doesn't look right in your system, check this pressure gauge first. That'll tell you a lot, because your filters are kind of your first step in your drip system, and keeping your water clean is really important. So check that first. That's usually the first thing I do when I get to a system that's not working is when it's running, not working properly, but still running. Check that, those pressures. Sure. If it's a high differential pressure, go ahead and backflush them. If you don't even have enough pressure, like if the pressure of your low side of your filters is less than 10 psi and you try to backflush them, you're not going to get enough back pressure to flush them, because it flushes from the bottom, uses that bottom pressure, goes up through the sand to clean them properly. What you ideally need is about 20 psi. So start closing zones till you get to 20, 25 psi, and then flush them to really flush them good. You can sit there and flush filters all day long at 5 psi, and you're basically you're back to the same point you started at. So. There is, so that your controller can flush them, or there's those blue aqua tees that control the valve to start flushing it. And I'll kind of go through some of that here in a bit if I have time. And on your sand filters, if I can get to the next slide, there's a backflush valve that limits how much water it backflushes. You can see it, that's back behind this junction box, like brass gate valve. That's something else that we try to set at the beginning of the year when we do our spring startups to make sure we aren't backflushing any sand. So what you want to do is run your system at its average operating pressure, backflush a few filters, and make sure there's no sand coming out of this backflush line. And then that you adjust it by opening it or closing it. And like I said, if we get it set at the beginning of the year, you shouldn't have to mess with it throughout the year. So most of the time, probably leave that shut unless something doesn't look right. Give Kurt or I a call, or one of us at NutraDrip, and we'll kind of guide you through getting that set properly. Because if it's too closed, too tight, we aren't going to lift that sand and pull the dirt out of it properly. But if it's too far open, it's going to flush too much of that sand out. And I got a personal story with that as well. On my dad's system, we were running effluent through it. The waste hog manure, and that being a fair amount dirtier, we were having to flush a lot more often, and we needed a little bit more pressure to overcome that differential pressure. So I went ahead and bumped our VFD pressure up by like 10 psi, and I didn't think to check this gate valve, but we had higher pressure on our system, so we had more pressure to flush the filters more. It flushed them more aggressively, and I didn't check it till later in the year, after when we started plugging drip lines up, that we had actually flushed an entire tank and a half of sand out and just dumped it out into where we dump our flush water. When we caught it because our flows started dropping off drastically. We knew our zone flows were supposed to be around 800 gallon a minute, and just daily it kept dropping like 50 gallons per minute. And we opened up one of our tanks, and sure enough, all the sand was gone, so we weren't filtering any of the manure or any of the pond water. I think I got some pictures of what the drip tape looked like. But with some serious water flushing and air flushing, we were able to clean most all of it out, and now our flows are back to what they normally were. So again, watching your flows and pressures to stuff like that can happen. Just to show you what the inside of the sand media filters look like. Here's a cutout of one and up close. There's little mushrooms with fine screens that the water goes through, but then these things are about 3/4 full of sand that water has to go through before it gets to here. And we added a fourth filter because we were running a lot of manure through on my dad's system, and we installed the fourth one over winter. And then this spring, we noticed we were getting a ton of sand out of our flow. We were flushing the main line, and we're getting a ton of sand out of it, and it looked like our filter sand. And sure enough, that fourth filter we put in, I had several of these mushroom screens broken out of, so it was just flushing the sand through. So we're keeping the NutraDrip inventory of sand down, I guess. He's using a lot of that up. So again, these shouldn't cause any problems mid-year. It's again after a new install. We usually, a problem would show up in the first year. And a lot of guys ask, how often do I have to replace the sand? there's probably people out here that know better than me, but I have not yet installed a system where we had to replace the sand because it got used up. It's always going to be there. Eventually, they say it gets wore down, maybe 5-10 years. Jason, you probably have a better idea. 5 to 7 years. Sure. Sure. So yeah, after a good solid flush, you still have high differential pressure. It's your sand probably getting wore down, and that's going to gradually happen over the years. But again, we try to, when we do our startups, we try to pop the lids off the top of these and just check the level of our sand, make sure they're good, because just if you do flush a lot, you're going to lose just a touch when it does backflush. And that's a sign of a good healthy flush too, probably. Here's another extreme of a system we found. This is actually Kelly Garrett's. He wasn't getting any water, or his flow was significantly reduced, and his pressure differentials were huge. He was backflushing and backflushing. I think his gate valve wasn't opened enough, so he wasn't flushing enough stuff out, and his well started pumping sand. So this is really fine well sand. It just kept building up and building up, even got lodged in the backflush valve. It filled the brim full of fine sand. So if you set that backflush valve properly, it should flush this fine sand out, but leave the heavier filter sand in the bottom. So that's something else to be aware of if you have to set that valve. But yeah, that wasn't involved with that. Kurt was the one that had to get all that sand out of there, but wasn't a very fun task, I don't think, as packed in as it was. I probably can't see this real well, but it's just a handful of that really fine well sand. Like it'll just be a coating on the top. It's going to be it'll be pretty obvious if you dig down in your sand in your tanks. You should be able to see the difference fairly easily, because it will stay on top. Here again, another picture of the clean versus dirty sand. I think this was sand full of silt and junk next to a handful of clean filter sand. So again, your sand shouldn't get dirty all that fast if it's flushing properly. But here's a picture of the drip emitters that they're on my dad's farm. But that silt, the drip line there was a layer of thick silt built up in there, and it started working its way in the drip emitters, started slowing our flow down. Here you can see that silicone flap and the pressure compensated tape. The flow path was built up. So it was just restricting our flow big time, but we were able to flush and clean it out. Sometimes you'll get hard water build up, and that's going to take acid to get it cleaned out. You'll start getting scaling. This was just dirt you could rub off really easy, but was still causing a problem. I think this next picture I have is iron buildup. That's again where I showed that slow decline in flow. This is what the emitters would start looking like. That zigzag flow path in there just gets built up with iron, and it doesn't happen real fast, but it can happen over several years. So being able to stay on top of that, and just call Cortland, he'll fix you right up, I think. Yeah, Ryan. You won't, in surface water, you very rarely have iron because the sunlight and oxygen precipitate that iron and it settles out. What you have in creek water or pond water, you more often have the silt and algae and stuff like that. That's fairly easy to clean up and flush out. It's your well water that's high in iron and manganese. Okay, winterization. Obviously, that's again something else you can sign up to do on our contracts for us to come around with our big air compressors and blow the systems out. And like Kurt said, like any system north of I-80, we definitely recommend that, because just to get our PVC pipes cleaned out, or all the water out of them so they don't freeze and break. In my part of the world, as long as we drain everything above ground, it's going to last all winter. So I'll kind of go through a few things of what you can do, and if Joel can't get to you fast enough with the air compressor, there's some things we can do to drain stuff above ground so that it doesn't freeze and break, and then he'll get there before the hard freeze sets in. So draining your main line at your lowest valve, so your blue valve, pick the one at the lowest part of the field, and you can go back to your design and see the topology lines. You should be able to, pick I think it's the blues, the lowest, and red's the highest on his lines. It goes color ordered like that. So just go there, pull off the air vent, and that'll drain your main line down to this point. And we tried to put a drain valve on that the lowest one. We think about it, that way you can open it up at ground level to finish draining the main line down at this amount of water that's in there. Also go around on your banjo valves and either fully open them, let all the water drain out, because that ball, when you close that ball valve, holds water inside it. That'll freeze and expand and break your flush valve. So if you can just open that valve and then either shut it or leave it cracked open, that will prevent that from freezing and breaking. Yeah, doing those things out in the field will help keep your startup costs down the next year if you don't have frozen and broken pipes. We haven't seen our black zone valves ever. There's really nothing you can do there's really nothing you need to do to drain those out. They have enough expansion room in there for a freeze and thaw. Those usually won't cause any problems. It's just your PVC pipe and your ball valves that need to get drained. Here. So then get inside your sea container or your filter shed. There's a fair amount of things you want to make sure you drain. Your filters will drain down. Obviously, that's just with gravity. They'll drain out through the main line, through that air vent you pull off. So those are fine sitting how they are. That command filter we talked about with the pressure gauge, drain that little Y filter. It's just a little screen filter. Just to get the water out of that, because it wants to sit in there. Those will freeze and break. I might mention while we're talking about those, if you are running effluent water or have a dirty stream water, it's good to check that little screen filter inside there once or twice a year to make sure you aren't getting buildup, because that cleans the water that controls your backflushing. It controls like gives the pressure sensors a reading. So cleaning that water if you're backflushing a lot, or cleaning that filter if you're backflushing a lot, is very beneficial. If that starts getting plugged up, then you won't be backflushing either. And also, if you can see here, the pressure sensors, those silver pressure sensors with the blue fitting on the end, pop that black tube off and let that drain out. Those pressure sensors are fairly sensitive to freezing, so draining those will prevent you having to spend a couple $100 on the sensors. This is our Fertile One fertilizer pumps. I know not everybody has them, but if you do, on the bottom, coming straight out of the center line of the pump, there's a little cap on that PVC line that'll drain most of your pump, get rid of your water out of your standpipe. And then there's also, I don't have a very good picture of it, sitting directly on top of that booster pump on that fertilizer pump is a check valve, and right on top of that check valve is an elbow. Pulling that check valve apart and popping that elbow off I recommend doing that as well, because that water won't make it backwards through the check valve. It just sits there, freezes, and breaks, and you got a problem next spring. And on this system, we have the water coming out of the well, going through a check valve, so it can't go backwards into the well, and then it goes up into the top of these filters. Actually, it comes in right here, goes to the top of the filters. This water has no way to drain unless I pull the plug on the bottom of this check valve. So pay attention to your system. We try to put a quarter turn ball valve or a spigot here. You can just open it up to drain this water out. So that check valve is preventing water from going back down the well. So we have to drain that just to keep this pipe from freezing. So if you take care of all this stuff by your filters and then the valves out in the field, that's going to winterize it for pretty good, so you get really heavy, deep freezes. And then, yeah, hopefully by that point, Joe will be there and have blown it out with the air compressor. So that takes, so the air flush, if we aren't familiar with that, we bring a big, like a 1600 CFM air compressor, hook in off on the back side of your water meter so it doesn't blow the air through the meter. And we just blow air through the system and then flush it out the flush valves. And by doing this, we can get a higher velocity of water and air through your drip tape, and that'll cause more turbulence and tend to clean out your drip tape more, would be better, clean it out a lot better. But again, it's not something we have to do unless you're north of I-80. Okay, I thought I'd go over some of how the valves work and how everything operates. I'm a guy that has to know how something works in order to fix it and learn it. So hopefully that does some good. NetFM creates a really great app called NetFM Control Valves. You can get it on Android, you can get it on Apple. Download it. It gives you technical guides. It gives you like plumbing diagrams for all your valves. It gives you hydraulic calculators to figure out size of valves. Helps you pick valves if you're interested in learning more about your valves. But the main thing is that the technical guides, it gives you really valuable information to tell you how your valves work, how they need to be plumbed. It gives you a troubleshooting guide as well. I don't know if I put a picture of that up there or not, but I went through and pulled up a plumbing diagram. This is a pretty standard configuration of all our valves. All our zone valves, again, the blue painted PVC valves, are pressure reducing. So it's taking whatever your mainline pressure is. Say you have 60 psi in your mainline, but your zone only called for 22 psi, like we mentioned earlier. This valve will take that pressure from 65 to bump it down to 22 psi or whatever you set it at. Actually, we got a couple different pressure regulators. We got a newer style and the older style. They work pretty much identically. There's a little bolt on top or this cap on top. You just turn it to adjust that pressure. And again, use your pressure regulator on your air vent on your valve to check that to make sure you're set at the correct pressure. So if something isn't working right, like you're adjusting it and the pressure's not going up or down, or maybe it's not opening, definitely verify all your plumbing. Make sure the direction of your flow of your water coming from your main line going to your zone, make sure that's correct, because it uses the water pressure of your main line to close and open your valve, and then also to control the pressure. Oh, absolutely. Yep. So on the 2950 pressure regulator, which is what I have pictured up here as well, there's a Phillips screw up top. So you have to loosen that Phillips screw in order to push this blue cap down to adjust the pressure. Otherwise, it just sits here and turns back and forth and doesn't do anything. It's kind of a child safety lock, if you will. So you got to back that screw off and get your pressure adjusted right. And again, really the only times you'd have to do this if you needed more pressure to flush something. I will mention too, on the 875 drip tape, the bigger diameter, like the max pressure you want to go through that is about 30 psi, and then the 5/8 drip tape, the max pressure you want is about 50 for flushing. But again, if it's set at what the design shows it should be set at, you should get a good flush. I pulled apart one of these zone valves just to kind of get you guys a better idea of how they work. There's an arrow on top, shows the direction of your water flow, and that's very important, but that's not going to change in the middle of the season, so you shouldn't really have to worry about it. But if you're confused when you get there, knowing which direction your water flows is pretty important. So in here again, the water flow is coming from my left going to my right. Inside we have a ballast that sits on top of there, and under normal circumstance, actually these are actually normally open, but when the valve, actually they're wired to be normally closed, so there's always water pressure sitting on top of this ballast. There's also a spring holding it down, so it's using the high pressure water from the main line holding down on that valve to keep it closed. And then when either the controller opens it or you manually open it with your aquative, it releases that water off the top of that and it pops it up, and then water can flow underneath. So then when it needs to start regulating, so if it gets up to 22 psi on this side, this pressure regulator is going to take water and send it back and start closing it. So it's going to start putting pressure on top of this to start closing it to get that correct pressure. So yeah, generally things that if something's not working right, if you see water dripping out of your vent tube on your pressure regulator, just a constant stream, and it runs for several minutes, that usually indicates the seals are getting bad in here. But again, normally everything should be right at, or you could get a rodent that comes along and chews one of these tubes, or a squirrel. Squirrels are bad at it. That could be something that's wrong as well, but it's a quick fix of a tube to get those working properly. There is a Schrader valve on here to check the pressure, and that's again checking the pressure on the zone side of it to get to that 22 psi. But it's just I think 6 or 8 bolts are on the outside of this to take it off. If you ever need to check it, just make sure your pump is off before you take it apart. Sometimes we've seen junk get caught on the bottom side of this, and it won't ever close. If your aquative is supposed to be, or it's set to close, and no water's still getting through, that could be a problem. Sometimes, after several years, sometimes these will start wearing out. You'll get a hole in them. I haven't seen very many that'll happen. That happens too, but that's something else you could watch. But again, if you've verified all the plumbing on the outside's good, and it's still not wanting to close, that would be something you could look at. Open this up and see what would be going on in there. Again, if your filters are working properly, you won't get any junk to go through it. And when I get to a zone valve that I know is not working, usually you got to figure out whether the problem's coming from the controller or whether the problem's at the valve. So if you just isolate the controller and use the aquative that's on there, that blue solenoid, it's got the auto open closed. So just run it in open or closed, and to see if the valve responds to whether it's open or closed. If that works, if it works from here, usually it's a controller or a radio or a control issue. But if it doesn't close when you tell it to close after a couple minutes, or it doesn't open when you tell it to open, then it's going to be a plumbing issue or issue with our pressure regulator. If these don't get set right, I've seen them work so they set themselves at a lower pressure. Like if that screw doesn't get screwed down or someone comes along and messes with them. So if these are set at 0 psi, you'll get no water through. They won't ever open up. Or maybe if they're even real low at a couple psi, you won't get any water to go through. So that's all stuff you can check. With a gauge, sticking that gauge on the pressure on the air vent or on that Schrader valve on that pressure gauge or the pressure regulator. You can sometimes hear it, but sometimes if it's running and the pressure on the main line is about the same as the pressure in the zone, you really won't hear much going through it, just because it's all designed not to make a lot of racket. Any other questions, I guess, on zone valves? I guess I should mention too, I guess like I did, there's an A, B, and a C on this aquative, and verifying those are correct. If you switch them around, sometimes they'll be normally closed or normally open. It'll switch that configuration. So it'll always have your valve open, and then when you turn it on, it turns it off. So just making sure that's all correct. I will mention it's different from your backflush valves. So your backflush valves on your filters take water pressure to open them and to start the backflush cycle. These take water to close them. A backflush valve's opposite of that. So, and it's another good test is to take this tube off the top of this valve, which I did in this example. Pop this tube off the top, and that'll tell you what this aquative is trying to do. When you open it, no water should come out, but if you close it, it will come out because it's trying to send water backwards or back to the valve to put pressure on top of that balloon to get it to close down. But if it is trying to regulate the pressure, it's going to send water as well because it'll just be a little bit less because it's trying to shut the pressure off a little bit. Then on your filters, if they aren't flushing right, you can just go ahead and take all these black tubes off of your backflush valves, because if it's trying to flush, it'll be sending water to that filter. So if you have multiple ones that are sending water to it and maybe trying to flush multiple filters at once, and that's a problem. Or if none of them are going when it's supposed to, that's another problem as well. Here's just another screenshot from that app of the aquatives. There's different variations of how they can be plumbed for normally open or normally closed. And the NetFM decided to switch up and make two configurations of them. So just pay attention to that A, B, and the COM or the command on the ports on those. And there's a whole bunch of other different solenoids and stuff that we have that I didn't mention. Just we probably don't have time for it, but this is our most common one, and they all work generally the same, just a different look to them. Air vents. So we've been having some problems with air vents. They can be kind of finicky. Usually it ends up, the problem with them is a piece of debris gets lodged in the float. So this particular, the 2-inch Pro air vents, you see a lot of them in your filters. If they start leaking, you'll hear them. They'll leak a little bit as they let water out. But if it's not, or letting air out, excuse me, they'll leak a little water. But if they aren't letting any air out and they're still leaking, generally there's the piece of debris caught inside. So if you shut your system down, make sure there's no pressure on it. The top unscrews from the base. And inside, there's a float, so if there's air in here like there is now, obviously that float drops down and that air goes up. But as this fills with water, that float goes up and plugs the orifice. But if there's junk in that orifice, you tend to have that's when you'll have it leaking water past. There's a little white, I don't know what, it's just it holds that flap up in there. You can pull that out, drop your float down, and inside there's where you'll see like a PVC shaving, or sometimes if you got grass or algae on your pond, sometimes those will get stuck up in there. There's just run water through it and clean it out, and then stick your float back in there. You have to line up your seal in a little slot that this plastic piece comes out of. But it's fairly simple to fix if you do need to, or if it is leaking on you. The taller, call them the 2-inch Pro air vents, they're a little taller and thinner. Sometimes those will get stuck, and sometimes they just get, that float in there gets dislodged, or it gets lodged, and you got to dislodge it by covering your hand over the blue elbow on it. And then cover it with your hand and let go, and that'll be enough pressure jerk in it to, enough water hammer inside that air vent to dislodge it. I may talk some of our systems, like I know the Hertz have it, where we control our valves with a gullet. We run a control tubing from the filters by the controller all the way up to the valves. So we will send air or water pressure up to the valve, and it has what we call a little gullet on it. Comes in the top. So if there's pressure there, it's trying to turn the valve on and off. That's just this would be in addition, or it would be in place of that aquative, that blue aquative. So the middle position is automatic, so it's looking for a command from your control tubing that's run up there from the controller. There's a number 2 and a number 3 on here. That indicate, I think number 2 is off and number 3 is on. So that's just a manual bypass. But if you're running it from your controller, make sure you're in your auto position. Just another piece to watch out for. I think that's pretty much all the slides I had. Now, obviously, if there's any questions, yeah, fire away. If not, obviously, Kurt and I will still answer our phones, but and anybody else, Logan, Joel, they all have phone numbers too. So yeah, I should have put them on the screen, shouldn't have I? But we appreciate everybody coming and learning, and yeah, look forward to harvest.